Good morning, good afternoon, good evening, good wherever you are, and welcome to another SNIA CSI webcast. This one is on multi-cloud storage, addressing the need for portability and interoperability. So before we go any further, just a few little housekeeping items I'd like to attend to. First of all, you'll notice on your screen you have the ability to expand this screen to your full desktop, which might be useful if you think that the viewing area that you have for the slides appears a little small. Secondly, you have the ability to ask questions of the presenters today, and I encourage you to do so. And if we have time, and we probably will, I will ask the presenters the questions at the appropriate time and place. And thirdly, we'd like your feedback. We'd like to know what you think of this presentation. We'd like to know whether you want more of it, and any comments that you might have about it are more than welcome. So, without further ado, let me introduce our speakers today. We're joined today by John Webster, who's the Senior Partner at the Evaluator Group. Is it morning where you are, John?
No, afternoon, 3 o'clock in the afternoon.
3 o'clock in the afternoon. Good afternoon, John. And Mark Carlson, who's the SNIA Technical Council Co-Chair from Toshiba. Good afternoon for you as well, I think, Mark.
Yes, good evening, Alex.
Good evening to me. I'm Alex McDonald. I'm the SNIA Cloud Storage Chair, and I'm from NetApp. So this presentation is copyright of SNIA, and basically there's no warranty here. If anything you do with this presentation causes your world to break into two, I'm afraid both halves are yours. And secondly, if you do use any of the materials from this presentation, and I'll be pointing at a link at the end where you're able to get a PDF copy, we would like you to actually use it as it's presented and not make any changes to the slides. That would be very good. Thank you very much indeed. But as I say, I will actually tell you where the slides are before we end. As to SNIA, at a quick glance, it's 170 industry-leading organizations. Storage Networking Industry Association covers a wide variety of vendors and others who are part of SNIA. We've got 3,500 active contributing members from those industry organizations. And overall, we've got 50,000 IT end users and storage professionals that follow us. You can learn more at SNIA.org, in particular from the technical perspective, SNIA.org/technical, and you can follow us on Twitter at SNIA. So, the agenda today, John is going to cover the first 3 bullet points. He's going to talk a little about the hybrid cloud survey that they ran. He's going to talk a little about hybrid cloud use cases, the objectives and the barriers to adoption, and cloud storage in its entirety. And then we'll turn over to Mark, and Mark will actually talk about managing data. How do you manage data in a hybrid cloud, and how standards, particularly emerging standards, can help with that process. So without further ado, I'm going to hand it over to John Webster, Senior Partner at the Evaluator Group. John, take it away.
All right. Thank you, Alex. Just by way of introduction, Evaluator Group has been in business since 1997. We've been focused on data storage and infrastructure since then, but we've also expanded our coverage to include server virtualization, performance, and databases. We've written our own performance benchmark called IOMark. We have a practice in data analytics, and another one in hyperconverged infrastructure. Another additional one just started recently in high-performance computing, and I now specialize in cloud for the group, and that's what brings me here. Just again, by way of introduction, as far as I'm concerned, I've been an analyst since 1990, mostly focused on storage. And I started actually in the mainframe environment, and I've worked my way, I don't know, up or down, depending on how you look at it since then. So, one of the things we've done this year are some comprehensive research studies that use primary research, meaning that we've gathered statistical data through surveys on enterprise usage of various kinds of things. I'm going to talk about hybrid cloud. We've also produced one this year on hyperconvergence. in the enterprise. Early next quarter, we'll produce one on changes in solid state, and we'll follow that with a look at high-performance computing in the enterprise. As far as I'm concerned, I'm going to be talking about hybrid cloud IT in the enterprise in the study that was released back in August. This was based on a survey that was conducted over the summer. We got a little more than 500 completed surveys, but what I did was I selected out of that 125 medium to large enterprise IT respondents and defined those as 5,000 or more employees, all users of hybrid cloud for the results that the brief results that I'm about to present to you. I also interviewed in depth, 30 to 45 minutes each, 25 of the respondents that we had in the survey to really sort of dig down into some of the responses that I got that I thought were interested in. I got a few quotable quotes out of those conversations as well. Oops. So here's some of the highlights from the survey itself, or the results of the survey. We saw that roughly 2/3 of enterprise IT basically says that hybrid cloud is their long-term future. And we think that the number one reason for that is this idea of agility. And, in the interviews, I asked about, their use of the word agility because I had it in the survey. And really everybody had a response to that. And what it really boiled down to was the ability to be responsive to user groups, as the idea of agility, and to be able to deliver a public cloud-like services delivery model to users that they were supporting. We also saw that though about 30% of them, even though they said they had deployed hybrid cloud, were just getting started, and that even though they might have been engaged in the hybrid cloud project for more than a year. And we think that is because these are very complex projects. They typically involve multiple people from different walks of the IT organization over months and sometimes years to put these together. And it really speaks to the complexity of these projects once people get started. In spite of that, though, 58% say they will increase their hybrid cloud workloads in 2017. So, even though these are complex, they're difficult, people are seeing value and are increasing their hybrid cloud workloads. But one of the biggest inhibitors, if you will, is, and I'll talk about this more as I go along, is getting things to work together. So complexity, it's sort of building a hybrid cloud architecture from multiple piece parts. And in order to do that, the typical sort of glue that people use to stick things together these days is the API. The API is the application programming interface is in a way the new middleware. And one of my interview candidates basically said that getting APIs to work out of the box is a myth. So everybody, when they work with APIs, has to customize them. It becomes a project within DevOps, for example, and people are constantly working to customize and update and maintain APIs to sort of put these projects together. And if you think that agility is the thing that you really want out of, let's say, a hybrid cloud infrastructure, APIs and getting them to work and constantly having to fuss with them really kind of slows you down. So the objective here is to try to get to the point where things work together more consistently, more easily, and that speaks to something called interoperability, which I'll spend a little time on in a little bit. So here are the use cases that we saw during, as we progressed through, as users progressed through the survey, answering questions. There was one that asked people what their current use cases were for private cloud or for hybrid cloud. And you can see here, disaster recovery is at the top of the list, application development, application mobility. As you go down, all the way down to workload migration, or this idea of cloud bursting, which is a difficult thing to do, and probably why it winds up at the bottom of the list of use cases. It's not because people don't want to do this, it's because people find it difficult to do. But the other thing that you can see here is a progression, to me anyway, starting with disaster recovery or business continuance as a use case, which is very, very common in hybrid cloud architectures. And I think that that's because people typically want to start somewhere in building these, and they want to start typically at the data layer. And they want to make sure that that works between on and off-premise instantiations of a hybrid cloud. And certainly one of the ways to do that is to replicate data. And if you're going to do that, you might as well have sort of a reason to be doing that. And disaster recovery and sort of enhancing your disaster recovery and business continuance capabilities certainly is something that you can do to lay a foundation as a data layer and get that working, understand how that works, what the performance looks like when you do that kind of thing. And then after that, people start to build on top. So they start to develop applications, they start to use hybrid cloud for application mobility, data sharing, and archive, and you can kind of go down the list from there. So this is a different look from the use cases. Here I was trying to find out what people really want to get going forward out of hybrid cloud. But notice, disaster recovery is once again at the top of the list, although now you see some different things that people would like to do longer term, like integrate legacy applications, use the hybrid cloud infrastructure to control costs. But this basically says where large IT, enterprise IT is going with hybrid cloud as they move forward. So that's sort of, I guess, in a way on the positive side, what people are using and what they want to do. Here's what they see as barriers, to the use cases and to the objectives going forward. And I'll tell you a little story about how I put this particular question together. What I wanted to do originally is to see whether or not public cloud security was this big issue, because for a number of years I've heard enterprise IT basically say we can't do things, all that many things in the public cloud, or maybe nothing in the public cloud because of security issues. This is very common, for example, in the beginning with financial services and healthcare, and it's still an issue in healthcare. But I really wanted to test that out. I wanted to see, really how important or how big a barrier public cloud security was. So, I asked the multiple choice questions. I said, here's some possible barriers. Choose all that apply. And I started at the top of the list with public cloud security, and then I kind of worked my way down. I threw network security in there because I've heard that might actually be even a bigger issue. And I wanted to throw one more in, so I got to the bottom of the list, and I included interoperability. I wasn't really thinking about that when I first started writing the question, but since I'm a storage networking guy, and interoperability years ago was this big issue, I figured, what the heck, I'll see if that's an issue as well. And I was just absolutely dumbfounded to see it rose to the top of the list along with external network security, and public cloud security actually fell down the list. And I think the reason for that is that, again, it's the idea of complexity, and if you're building a hybrid cloud, you're building it from sort of multiple piece parts. I mean, there are people that build hybrid cloud from scratch, using OpenStack modules, for example. And you got to all stitch all those things together. And remember that, what you're really driving to is agility, the idea that you're going to try to deliver the public cloud experience to your internal cloud users. And so anything that sort of gets in the way of that is going to be a barrier. And it's not really security now, it's really the interoperability between piece parts, or the interoperability between what's going on in your environment versus what's going on in a public cloud environment. And that turns out to be the biggest thing that people have to overcome as they progress forward with these projects. So here are some of the ways that people use, IT uses storage for hybrid cloud. Again, disaster recovery rises to the top of the list, but now you see some other things that storage does in a hybrid cloud environment. So there's increasing use of on and off premises storage, and the integration between on and off premises storage for storage tiering, as well as off-premises archiving. And so Mark is going to actually go into a little more detail in his presentation on data protection, disaster recovery, storage issues, tiering and archiving for longer-term retention as you go from private to public cloud. So let me just leave you with a few of the takeaways, not only from the survey itself, but also from other research that I've done. What I found in the interviews was that hybrid clouds are really multi-clouds, and again with lots of moving parts that give it this complexity. So, yeah, pretty much everybody I spoke to has a commitment to AWS and a commitment to Azure. And so what they're trying to do is build a cloud environment that includes on-premise and then off-premise that could be, and probably is both AWS and Azure, and may also then include IBM and Google Cloud Platform. So it's not just this idea of on and off premise, it's the idea of on and off a number of different off-premise sites, sort of all integrated together. That's the direction that people are trying to move. Data protection, disaster recovery, and business continuance are critical capabilities now for hybrid cloud, and will continue to be, I believe, critical capabilities. It's not just like we built it on this data protection or disaster recovery layer, and we're going to move and leave that sort of layer of data protection static. No, people are going to continue to expand that and use it, and continue to rely on it and build critical capabilities on top of it. Interoperability of the data layer is key. And so if you're going to put these things together, you have to create a data layer. And the idea that you can move data, and I hate to use this word seamlessly, but it's out there and people use it. So this idea that data flows is absolutely critical to the functioning from a performance standpoint of the hybrid cloud, and interoperability, I believe, is key. And finally, I'll leave you with this. Up to now, open source build-it-yourself projects, cloud projects, this is in some other research I've done, have an 80% failure rate among enterprise users. And you can argue with me, that's fine. John at evaluatorgroup.com is just that with what I've seen in the research I've done. And the reason, again, for that is these things are complex if you build them yourself. Lots of moving parts, again, and this idea that you need to have interoperability and the ability to sort of stitch together these things in a way that's predictable, that works, that you can test, and you can, and this is important, put into a production environment. So those all the things that you need to do. Interoperability is key to all of those. And with that, I'll turn it back to you, Alex.
Thank you, John. I've actually got a couple of, well, I've got an observation, first of all. For mainframe, it's always been downward direction. I'm afraid I'm an old mainframe hack myself. So, just to give you a perspective on that one. I'm interested in this failure rate. It's incredibly high. And the question I would have is, are there any particular kinds of projects that are failing significantly? Are people being too ambitious? Are they trying to do the wrong kind of project that causes them to such a failure rate? What's causing that? I mean, it's an enormous rate. I know in IT and in enterprise IT in particular, failure is often more common, I think, than people understand.
Yeah,
but that is such a high figure.
Right. Well, let me define failure. Okay, the failure here means getting it into production. Okay, and to our organizations, IT organizations, production is a big deal. Production status, getting something into production status, takes some period of time. Sometimes for people, it takes 2 years, to achieve that, sort of production level status. But when I talk to people about this, it's really, they've had experience with OpenStack, and OpenStack in the enterprise, let's say outside of telco or outside of colleges and universities or, organizations that have a lot of technical expertise, OpenStack has not done well. And those are the most common, let's say, build-it-yourself kinds of open source projects, cloud projects that are out there, and there are two reasons for that. One is that people spend an inordinate amount of time undergoing test and regression, or regression testing to get things to work. And the reason for that is that typically you don't have the expertise in-house. So you either have to go outside and find it, or you have to, just train people internally. And one of the issues with training people internally is once they get to understand something like OpenStack, that they run off. Other people hire them. So it just becomes it becomes a long, involved process where at some point people sort of stand back and say, well, we've spent this amount of time, the average is about 2.5 years, and this amount of money, and the average is $4.5 million, trying to stand this up. If we can't see it getting to progression or getting into production, then we'll pull the plug, or at least put it on the shelf, and that's typically what happens. Okay, so that actually goes back to your point about getting APIs to work out of the box as a myth. Absolutely, and interoperability. So it's, you really, when you look at a statistic like that, you understand how important interoperability is. Okay, good. Thank you very much, John. So, without further ado, I'm sorry. No problem. I moved forward too fast there, so I'm going to pass it over to Mark Carlson now, who's going to talk about managing data and how standards can help. Mark, I understand, is not a mainframe guy, so we'll just have to forgive him his little slip in the past. Mark, over to you.
I don't put it on my resume anymore.
Okay.
Yeah, all right. So, John mentioned that a big use case here is disaster recovery. which obviously means that you want to get all of your data into the cloud at some point, even though you may be serving it up locally for some time. But data management is something that's actually lost a step since everybody's been moving to the cloud. It used to be that you would have multiple data centers and one data center could take over for another data center. Here with the hybrid situation, the cloud is your other data center. And so you want to get all your data up there, but now you need to manage it. You need to protect it. You need to have policies around it. And so how do you do that? Because the local situation is usually completely different from the cloud situation, right? So you may have quite a few applications or data services that you deploy internally. Maybe they're not cloud-oriented, even private cloud-oriented. Maybe they're just software that runs on your NAS boxes, right? But you do have, typically going to have proprietary interfaces for each one of those data services. You may have multiple tiers before the primary location becomes a cloud. You might store it on SSDs locally, you might move it to hard drives locally, maybe even tapes locally, and then you move it to the cloud. Now you've got additional work to do to manage that data once it's in the cloud. How many copies of the data do I need? How long do I need to retain individual files? And there's multiple cloud tiers as well. You have your sort of primary high-speed Amazon S3. You've got Amazon Glacier. You can even throw your files onto solid-state drives in the cloud. So how do you manage that tiering as well? And is it a completely different interface from what you're using locally? So you can see that managing the data becomes a big roadblock, as John has said, to getting this stuff working and then keeping it working in production. All right. Oh, you click it and it goes late. All right, I think I'm on the right slide. So what would be the ideal situation for these hybrid cloud customers, right? They would like to be able to comprehensively manage the data no matter where it is at this particular point in time, right? What tier should be hosting it? Should it be a local tier? Should it be a cloud tier? How much protection should it get at this point in its life cycle? It may be protected very well at the beginning of its life cycle, but at the end of its life cycle, you have one copy that you're just waiting to delete. What are the quality of service requirements right now? If I have thousands of users accessing this file simultaneously, such as a public video, that's a completely different quality of service requirement than a file that's just been circulated on email. So what about long-term retention and archiving? You should have policies for which files need to stick around under various government regulations. And keeping those around may mean actually moving them from one version of Word to the next version of Word. How do you do that? Which files should do that? And then finally, when should it be deleted? Because oftentimes the file will be a liability past the time you're required to keep it around. Now, there's all sorts of point solutions in the space, but really you should be asking vendors the right questions here. How do I do this? What do you do? What can you give me? Is it the same between the local data and the cloud data, right? Almost always you're going to get answers back that say, well, we don't do this, we don't do that, and you have to piece it together from multiple vendors. But still you're not getting a comprehensive solution. So you might as well solve the problem yourself with your own data management automation and do that in-house, and then that has implications on the APIs that John was talking about. So now you're writing this automation software. You need an API into everything that's in the cloud. You need an API similarly to everything that's local as well. So how can standards help? Well, SNIA has a standard called the Cloud Data Management Interface, and in particular, what CDMI standardizes is a way to manage your data in both the public and the private aspects of your hybrid cloud. The approach that's used is to use metadata. And metadata is essentially data about data. But this particular metadata is used to describe the requirements for that data at this point in its life cycle. And that metadata can then be set on individual data objects. It also can be set on containers of objects, similar to a directory. And then those requirements are essentially inherited by everything in that container or directory. And you can obviously have containers within containers as well. And at any point in this hierarchy, you can override the requirements from the parent for all of the children. So that comes into play along the lines of what John was mentioning, of having a interoperable set of APIs. Because if you can standardize on this metadata for your data, for your organization, doesn't matter if any of the vendors even comply with it, you can have what you want, a comprehensive scheme to manage your data. So this metadata, besides being an API, ends up being kind of a contract between whoever owns the data and has set that metadata and the underlying private or public cloud systems that are trying to meet those requirements. That implementation, that automation software that either you or a vendor wrote can now understand what the requirements are in an interoperable and portable manner. Interoperable means that the interface doesn't change, and portable means it moves. It can be ported. The automation software can be the one that invokes these data services, invokes a backup, invokes some other data service to protect or make available or replicate or stage your data to the various tiers, for example, that correspond to the requirements that have been set on that data. And then the portability aspect comes in when you want to move your data between the private and public portions of your hybrid cloud. So the metadata sticks with that data, and when you move it into the cloud, the automation there can interpret it in the exact same way to perform the cloud data services that are going to meet those same requirements. So that same metadata, it's a contract between the owner of the data and the cloud system, is interpreted identically, both locally and remotely. So here's some examples. What are we talking about here? Well, let's say your data has a requirement for a given latency. It needs to be very close to the application that's using it. In order to do that, what you do with the CDMI standard is you set a latency hit. And that latency can be used by the cloud systems to move the data closer to the app, to stage it on faster storage, like an SSD, or maybe even persistent memory at some point. And then that automation that's sitting behind that metadata interface, if you will, is going to drive the staging. You can lower the latency hit or lengthen the latency hit, and that means the cloud can move it to some cheaper, slower storage. Bandwidth is another latency, another QoS hint, and it can tell you how fast you need to be able to serve up that data. There's also standardized protection settings for RPO and RTO, which are standardized terms in the industry. Things like redundancy, the number of copies of the data, and whether and how geographically distributed they are. The geographic location of the data, which countries may host the data, and more importantly, which may not. And this comes into play especially with the laws that have been and are being put in place in the European Union and other jurisdictions. For data preservation and retention, you have things like retention time. How long should I keep this file around? Administrative holds. If I get a subpoena for the data, I have to make sure it's not deleted, even if the retention time has expired. And then auto deletion, so that you don't have to have somebody go through and periodically trim files that are past the retention time. So the CDMI standard is looked forward to the time when cloud storage is able to do these kind of data services. Not all of them are available through even a proprietary API at this point. But it's expected that just about anything that you can do as far as a data service locally will have some equivalent kind of service up in the cloud at some point. So, public cloud providers are still lacking in these data management features. You're still, in the public cloud, you're still sort of managing the data services directly instead of managing the data and having the data services understand that via metadata. But you don't need the cloud providers to implement CDMI directly in order for you to benefit, because you can write automation in the cloud to do the kinds of data-driven data services that the cloud providers have not yet provided. Today, you can add CDMI metadata to your files and directories and use this to drive your own automation. In both the public cloud, where you're invoking these data services, and more as they become available in the offerings, and your own local automation, where you're invoking local data services to meet the specified requirements. So as a result, you can see that you can start to get a handle on a comprehensive hybrid cloud data management. You can start to realize the difference between a prototype cloud environment that you're still having trouble getting to work and a production hybrid cloud environment where everything's operating seamlessly according to your business concerns and your customers' actual data requirements. So that's all I have. Back to you, Alex.
Thank you. I've actually got a couple of questions for you as well. And my one question is, we've talked about CDMI in the past, and we've talked about brokerage and arbitrage in terms of cloud storage services and other cloud services. Are there commercially available products? I don't want you to mention them by name, but it's something you and I discussed about, the fact that there are products that use CDMI and use them in the way that you've described. And I think that's important to note.
Yeah, I believe so too. We're starting to see that now in the industry where you can go and buy a solution for this from vendors that will store your data locally and store your data in the cloud and move the data back and forth between local and the cloud based on this CDMI metadata, based on this CDMI standard. So it's not unreasonable for you to put that in an RFP today and have some folks actually be able to satisfy that RFP. And as a result, you're going to get a solution that's much closer to what you need for a production environment, for production hybrid cloud environment with true automated data management. Thanks for asking that question, Alex.
No, thanks for asking it, Mark. I know you and I have discussed this before, but how important it is to try and not only talk about the standard, but also the fact that there are commercial solutions to this. So thank you very much indeed. Thank you both to John and to Mark for their contributions today. Thank you to our audience for attending. As you leave the webcast, I'd really like to thank you for being here and ask you to rate the webcast. We do value your feedback. We really like to know how we're doing and whether we're doing the right things and whether we're doing them well. So leave us feedback as you leave this presentation today. The webcast is going to be available on demand along with this on the website at SNIA.org. In fact, I'm going to put into the audience announcement the actual link to the website, which I'll do right now. Oh, there it is. You can download the webcast like that, and there's the link. You'll see it on your announcement screen. There's also going to be a Q&A from this webcast, and including some of the questions that we asked today, and they'll be on the SNIA Cloud blog. You can see it there, www.sniacloud.com. And if you're interested in more cloudy issues from SNIA, then you can follow us directly on Twitter on @SNIA-Cloud. But in the meanwhile, thank you, John, thank you, Mark, and thank you, everybody, for attending. And I'll end this presentation now. You leave us feedback, been very much appreciated. Thank you.